Hi. Now we discuss SN1 mechanism. The SN1 mechanism. There are two mechanisms especially in alkyl halides, SN2 and SN1. SN1, let us talk about SN1 reactions or mechanism. For this mechanism, tertiary alkyl halides are best suitable. Tertiary alkyl halides. Tertiary alkyl halides are best suitable. Slowly, it means 3-degree alkyl halides. These are 3-degree alkyl halides undergo SN1 mechanism. Means let us take the example tertiary butyl bromide. Tertiary butyl bromide. Tertiary butyl bromide is the best example for this. This reactivity, SN1 reactivity decreases from 3 degree to 3 degrees highest and then 2 degree least in 1 degree. That is the order of reactivity of SN1 mechanism. Tertiary butyl formula CH3 taken thrice CBr. That is a tertiary butyl bromide. Okay, this compound undergoes substitution. What is the full form of the SN1 nucleophilic substitution? Unimolecular. SN1 means unimolecular. One means unimolecular. Unimolecular. N means nucleophilic. Nucleophilic. S means substitution reactions. Nucleophilic substitution reactions. Yes, that is the full form of SN1 substitution. Yes, here bromine atom or that part is a leaving group called it leaves out of in the reaction. So it is a leaving group by another nucleophile, strong nucleophile. When strong nucleophile, this is also nucleophile, but when stronger nucleophile approaches, this weaker nucleophile leaves from the compound. So leaving group, Br is the leaving group. What is the structure of butyl, tertiary butyl bromide? Yes, tetrahedral CH3. 3 CH3 groups are there, 3 methyl groups. Methyl groups are bulky groups and bromine. That is the structure of tertiary butyl bromide. Now we are adding, so but this is a polar bond. Our bromine gets a partial negative charge, carbon gets a partial positive charge. So bond becomes polar and weaker. So whenever strong nucleophile, OH minus is a strong nucleophile. So it is another topic. Why bromine is weaker? Why OH minus is a stronger? We studied in the first year. This is secondary syllabus. First year we have learnt in the that ionic equilibrium and acids bases equilibrium chapter we have learnt in the acid basic theories. Okay, Bronsted and Lowry theory tells why it is weaker, why it is stronger. Let us, okay. Now, when OH comes and it wants to substitute bromine, but since both are negatively charged, our OH group cannot go from this side. So it cannot go from back side also, because these are bulky groups. Bulky groups exert some repulsion, which is called steric hindrance. Steric repulsion or steric hindrance. Hindrance means these 3 groups, since they are bulky, they do not allow OH group to come from this side, other side. Anyhow, this side it cannot go because both are negatively charged repulsion. Here, steric hindrance. One side repulsion, another side steric hindrance. So, at that time, what happens? Reaction takes place 2 steps. In the first step, which is slow. First step is slow. What happens? This bromine goes out. It leaves. Okay, how does it leave? Leaving, taking the electrons itself and leaving the positive charge on the carbon atom. Yes, 3 methyl groups arranged like this: trigonal, planar, positive charge on the carbon atom, Br minus. Yes, it leaves. Bromide ion leaves. So it's because now OH minus will attack from any direction, because here 120 degrees, everywhere 120 degrees there. Here also 120 degrees. Our OH hydroxyl group can attack the this positively charged carbon from any direction. Okay, then we get a hydroxyl group substitutes Br minus, and the product will be mesomer, that is carbon CH3 OH. Yes. What is it, sir? Tertiary butyl alcohol. Tertiary butyl alcohol we are getting. Alcohol. Yes. First step is slow step. Second step is whenever it takes OH plus OH minus OH minus hydroxyl group attacks the positively charged carbon atom and gives a product tertiary butyl alcohol as a product. This is second step is fast. Because why second step is fast? Because reaction takes place between the ions. Positively charged carbocation, negatively charged hydroxyl group. So reaction between ions is always faster. But in the first step, only one is ion, another is not ion, just polarity only. Here complete ions. So the reaction between the ions is always faster than the first step. First step is slow step. So since the first step is slow, it decides the rate of reaction. So it is called rate determining step. This is about complete about SN1 mechanism. Thank you.